Okay, this is section 4-4, day 2. So pause the video and give this little quiz a try, and then come on back and we'll walk through it. Let's review the equation for slope. M equals
y2 minus y1 over x2 minus x1.
So who can substitute the values like you did? Ellie.
I did -1 minus -1, so it's, and then over 13. Wait, over 12 minus -1, which equals 16.
12 minus what?
-3.
Okay, so she's actually using the first point here as our point 2, right? If we look at this. But we just need to make sure that we have a point here, x, y, and we do. And a point here, which is -3, -1, and we do. And what do we have in our numerator, Ellie?
0.
0 over what?
Over 15.
15. And what does that equal?
0.
Very good, because we can divide 0 by something. Okay, so this one's a little trickier because we have an unknown in our ordered pair, right? So that's different. So how did you set this up? Nella?
I had 4 over 1 equals 15 minus 7 over -10 minus x.
Good. So we look here, and then we have a point under itself, right? X under y, -10 under 15. -10 under 15, yes we do. Here it is, okay. And then we have x over 2 underneath 7. So we have the points stacked the correct way. This is good. And so why did you put a 1 in that denominator?
Because you cross multiply.
Good, so she's going to use cross product. The other thing we can do is we can simplify this numerator, right? What is that?
That's 8.
That's 8. So when we use our cross product, I'm going to write this over here, right? We have on the right side, if we bring the 1 up, we have 8. But what is on the left side? Nada.
Well, this one's on the bottom. I did 6 to -5 minus x.
Is -10 being divided by 2? It's not. And that was something someone did in the last class as well, but it's not.
You can do -40.
Right, so we're going to leave the 4 and bring the entire term. This is called a binomial. There are 2 terms here being added together, right? We have a -10 plus a -x over 2. So bring that up. -10 plus -x over 2. And that's why she's saying -40. So you distribute, you have -40 plus what?
Plus -4x over 2.
-4x over 2 can be simplified, right? What is that?
That's -2x.
-2x, right? -2x. And I'm just trying to save room here. So now what will we do to isolate x? Add 40. And I'm just going to write this, squeeze it in. 2x equals what now? Adding 40 to both sides, so 48. -2x, I dropped the negative. Okay, and so now to finish it, we just do what? Divide by -2, and x equals -24, good. Okay? And if we plug that back into this over here, what is -20? What's the negative of negative? What's the opposite of -24?
Positive.
24 over 2 is
12.
12. What is -10 plus 12?
A 2.
2. And so this whole thing would become 2. 8 over 2, does that equal 4? Yes, it does. Good. Okay, let's look at your assignment. Okay, so just a quick little lesson for the second day today. We're still working with slope. And now we have this word rate, which we have used before. So slope, what are the R words that go along with slope? Slope equals?
Rise over run.
Good.
Yes.
Okay, so we recall that slope equals rise over run. And what do you know about a rate? We've talked about rates. Kate?
Is it scale or model?
Okay, so she's thinking of that, of scale. We did talk about rates during that time, but scale actually doesn't have what rates always do have.
Isn't it with like dice and like you can do like a rate with dice or wait?
You're thinking probability, odds, and things like that, because it's a ratio again. So rates are like ratios in that they look like a fraction, but we have two different things in rates, right? What's different? Or give me a rate example. Miles per hour, very good. So what does that have?
Calories per serving.
Calories per serving, we're getting rates, this is good. So what are those two different things? Units, good, two different unit forms, okay? Two different unit forms. So here's rate again. Rate of change is the same thing. Rate of change is comparing two different quantities. We just heard miles per hour, calories per serving. We could say students per class. There are infinite possibilities for our rates. And we're just beginning to work on linear equations. And when we're facing real world problems, rates are always going to be what part of our linear equation? Do you think? Because they are what they are. They're fractions. And what section are we in today? And we're talking about what? Slopes, right? Slopes. So rates, when you face them in a word problem, like calories per serving or miles per hour, they're going to be your slopes in your equations. We haven't talked about it formally yet, but you know slope-intercept form. Slope-intercept form is y
Equals mx plus b.
Good. So it's going to be, this is just a preview, but you all know it's going to be found here. When we find a specific rate, we're going to be inputting it here for our slope. Okay, so really key in on that. That's really critical. If you look at the front cover of the math book, you see slope-intercept form. Algebra 1 is all about that. You got to know it inside and out, how to deal with linear things, and then we apply those kinds of principles to all these other kinds of equations. But you really need to be soundly, knowing your linear stuff. Okay? Okay, so here is a question you'll have today. Find the rate of change given this kind of data. So find the rate of change in cost with respect to time. And here we have a horizontal table of values. So if you're going to find the rate of change, we're looking again for the S word, the slope. And so how were we finding slope yesterday? Good. Excellent. y2 minus y1 equals x2, over x2 minus x1. So what do we need for slope? To find slope, we need x and y, one x and y? Two. We need two. What are those xy things? Points. Good. They're points. So do you see 2 points here?
Yeah.
How many points actually do we see here?
Three. 6.
Do we see 6 points?
Well, we see like 3.
We see
3.
Very good. We see 3. Kyle, tell us. Give me 1 point.
Come on, 4.
Okay. So look at that. Could you rewrite this way? Yes. And we could, let's say this point together, this is 6.
Yep.
Okay, and you could do that with all of them. If you were more comfortable seeing them in their ordered pairs, you could place them that way. And now, do you have enough information to find slope? Yes, so go ahead and pause the video and find slope. Okay, so Hank has given us the slope formula, input of 2 points correctly, right? And we now have $45 per 2 hours. But that's not typically how we find rates, right? We don't say, I'm going to spend $45 every 2 hours. What do we say?
22. Wait. 22.5. Yeah, $22.5 per hour.
How did you do that, Jack? How did you do that?
Because you did 45.
You divided. But because we're dealing with money, we usually add that 0, don't we? So $22.50 per hour. Now, we have a rate. Has a single number and 2 different unit forms. Good. And we're on our way to using that in slope equations later, right? Okay, and so you may begin.